Alright miners, here's the deal. We have 3.6 billion square kilometers of Minecraft world to conquer, industrialize, and develop, and I'm sure as hell not doing it all by hand. So we're gonna have to automate, build advanced control systems, and push the limits of computer science in Feed the Beast Minecraft. Welcome to Datacraft. So here we are, one day in, and I already feel like I've done too much manual labor for an automation focused series. So today we're going to build our first mining turtle. We're going to also write our first program and use it to dig our first mineshaft. To do that, we're going to need to acquire diamonds, redstone, and coal. While I go get all that ready, we're going to talk about our basic software architecture. What is a turtle? What can we tell it to do? And how do we use one to dig a mineshaft? A mining turtle from the CC Tweaked mod is a very simple machine. We give it very simple commands like turtle.forward, turtle.back, turtle.up, or turtle.down. Each of which will make it move one block in the respective direction. It can turn right or turn left by 90 degrees and dig, place, detect, or inspect the blocks above, below, or in front of it. It can drop and pick up items, manipulate its internal 16-slot inventory, interact with chests, attack mobs, and consume furnace fuels to keep itself running. That is mostly it. So how do we use something basic like move forward one block to achieve dig an 8x8 mineshaft all the way down to bedrock, without a truly ludicrous amount of copy-paste? The answer is abstraction. Turtles use the Lua programming language with features like loops, conditionals, and functions. We're going to use these to build ourselves a library of more useful commands, and hopefully, after today, we're never going to need to use any of these base turtle.forwards base commands again. For example, for turtle.forwards, often we need to move several blocks forward, not just one. So let's make our own forward function that takes a number as an input and moves the turtle forward that many times. When we use this command as so, we expect the turtle to move forward 4 blocks. All of the messy looping behavior is abstracted away. We don't need to worry about it. But what if there's a block in the path of the turtle? We execute the command and come back to find that it's only moved 2 blocks. Our abstraction has failed. We call this a leaky abstraction. So let's plug the hole and dig out the block before we move there. This is good, but what if there's gravel in the way and more falls down after being dug? Our abstraction starts leaking again. So let's put in another loop that will keep digging the block out until a move succeeds. Phew. There is another problem here, though. What if we want to perform an action after each one tile of movement? For example, if we have a farming bot, we might want to move forward, then check the crops below, and maybe harvest and replant the crop. Fortunately, Lua has a cool feature where functions can be passed into other functions as input. We'll change our forward function to accept 2 more inputs, pre and post. Pre is a function that gets executed right before each movement, whereas post gets, well, see if you can guess. We'll set up the code so that if either one is left empty, a do nothing function will be executed instead. Now we can put our complex farming behavior into a single function and pass that into the post input. Problem solved. And now we have our own move.forward, a level 1 abstraction. We can do something similar for move.up and move.down too. That's still not good enough to make an entire mineshaft though, so we're going to write a second level abstraction, hgrid. We pass in 4 distances, forward, rightward, backward, and leftward, to the edge of a 1 block high flat rectangle relative to the turtle. This function will then construct a path that takes the turtle through every block of the grid before returning to its start location. Each line of movement will use our old move.forward function from before, and hgrid takes the same pre and post handlers, which get passed down to the lower level abstraction. Finally, we can build our third level abstraction, the goal of this whole exercise, which we'll call mineshaft. This should be pretty easy to understand. Dig out a horizontal grid, descend 1 block, dig out the same grid, and repeat. We can speed this up by digging 3 layers at once by mining out the blocks above and below after every movement. Alright, thank you for going all over the theory like that. So we have our turtle here that we've made from a computer in the world, and we named it AlphaBot. For the time being, I'm not going to go into detail about how I'm getting the code that I write onto this machine, but for those interested, I have written a script called Go that will both launch my programs, but also before that, download all of my latest files from the GitHub repository using the API, install them on my machine, and then run the file in question. So if I just run Go itself, you can see it's getting the files. We've got 2 folders of files here. We've got in our file system libs, these are libraries, which have got dig, move, that's the one that we were talking most about, position, secrets, and util. Secrets isn't in the repo, but it contains my GitHub API key, so I put it manually on the machine so that it knows how to download the files from GitHub. And then we have our scripts, which have our proper full script, another copy of Go, Hello World, and mineshaft. So if we, for example, run Go Hello World, it's going to synchronize and then run Hello World. If we look at scripts Hello World, all it does is print Hello World. If we instead go look at our mineshaft, then you can see it takes in as arguments the dimensions of the mineshaft it wants to dig, how many blocks left, how many rights forward, how many blocks left, right, forward, and then how deep we want it to go. Position is something we didn't talk about. It's another library I made that's a wrapper around the move library. All it does is it keeps an XYZ coordinate of the turtle's current position, and it just increments or decrements each of those values by 1 every time the move library moves us 1 block. And the cool thing about that is that you can get behavior like, if your inventory runs out of space, go back to the block that you started at and deposit all of your inventory in the chest there. So you can see we've got this function post move. This is what we pass into the post parameter whilst we're digging our mineshaft down. And there's a few things here, but we've got things like try refuel that will try and refuel the turtle using coal if the turtle fuel level is too low. And then you've got this one, which is exactly what I described. If we've got no free inventory spaces, go back to the starting coordinates, drop all of everything but 1 stack of fuel off, try and refuel, go back to where we were before and continue. And this is the main loop of the mineshaft. While our Z position isn't as deep as we need it to be, go down 3 blocks, then this cover grid and return, which is the hgrid function we mentioned before, and then at the end go back to the starting position and drop everything off. So let's try this out. It's turning to nighttime, and I've dug up and registered a couple of points on our cam mod so that we can take a cool time lapse of this thing. One important thing is to give your turtles a name, because if you don't give them a name, it'll forget every single time that it'll forget everything, all of its files, all of its settings, all of its fuel level every time you dig it up. Okay, so here's our 8x8 space. This is what we're going to dig all the way down to bedrock. Our current coordinate is... I don't have access to F3 right now. 1, 2, 3, 4, 5 above sea level, so about 69-ish. So we want to go down about 57 blocks. So we're going to place this here at the corner facing the chest. We're going to run our mineshaft program, and this is an 8x8 area that we're digging out. So we want to dig out 7 blocks to the left, 0 blocks to the right. It's going to be a total of 8 blocks of depth. I know that's a bit inconsistent. I should change that. And 57 blocks down. Let's give it some fuel so that it can get started, and with a bit of luck, oh, hello. What are you doing? Okay, our drop everything except 64 fuel is obviously not working correctly, but it seems to have figured things out. Cool, and start at the right place. Looks like I made it go down before it does anything, so we're going to have to dig out this top layer ourselves, but then we can just sit back and watch the turtle do all of the difficult work. Fantastic, and now we can take a nice big long time lapse of this thing. It's can start 10 minutes, shall we say? 20 minutes. Alright, note to self. Even when you're in cam mode, you can still die by running out of food and starving. Oh my god. Oh boy, okay. Okay, so you might have seen that there were a couple of bugs on that thing, particularly right after it came back to deposit its inventory. It did a lot of oscillating back and forth, and that's just down to a flaw in how it's apparently depositing all of its fuel as well, even though the function is called deposit all but 64 coal. So need to work on that. But anyway, you get the general idea. I'm going to shepherd that thing as it continues to dig all the way down to bedrock. And next time we're going to start our very first branch mine run by turtles. And the cool innovation that we get to work with here is a thing called depth first search, which is going to be our first proper algorithm. And it's going to be how, whenever we encounter an ore vein, we make sure to dig out the entire vein, which is essential behavior for any good branch mining turtle. Until next time.